Okay, so our last video, I was trying to go to the notes that had the history of the the periodic table. So, and that was question number 24. List the names of scientists that discovered part of the atom/periodic table in their discovery. So I wanted to show you that real quick. If you go over to, here's the video for our notes. Democritus, he's famed with, he was the first person to name the atom. John Dalton, he came up with what we call a solid sphere model, where he said the atom is a solid sphere that can't get any smaller. Elements are made up of atoms that all have the same mass, and compounds or atoms of different elements combined. Dmitry Mendeleev, he developed the first periodic table of elements. Then the next person is J.J. Thomson. He developed what we call the plum pudding model, where he said the atom is divisible. It has positively charged sphere with negative particles embedded throughout, and this is a model of that. The next person is Ernest Rutherford. He developed what we call the nuclear model. He used the gold foil experiment to come up with that. He said the mass of the atom and its positively charged particles were mainly in the nucleus, with low mass negatively charged particles surrounding it. So he came up with this diagram right here. The next person is Henry Moseley. He discovered that the number of protons is unique for every element, and he, because of him, is how we have our periodic table arranged today by the atomic number. Niels Bohr is the next person. He came up with the Bohr model of how we draw the Bohr model, which is the electrons in the orbitals around the nucleus. The next person is Schrödinger and Heisenberg. They developed what we call the electron cloud model. They said that the electrons are surrounding the nucleus, but they move so fast that we can't see them, and so they describe it kind of like a cloud. The next person, I think that's all the people. Okay, so let's go back to the questions. How many protons does lithium have? So let's go to a picture of our periodic table. Let me just pull up. I think I deleted my periodic table picture, so I'll pull one up real quick. When you take your semester exam, you will have a periodic table in front of you. So I did have one pulled up, and I had deleted it. Let me find a good one here. Let's see. I think maybe this one will work. Okay, so lithium is right here on the periodic table, and the question is, how many protons does lithium have? So on the periodic table, lithium is number 3, and so if you go, the number of protons is the same as the atomic number, so lithium has 3 protons. What is the atomic number of lithium? It's the same as the number of protons, it's number 3. What is the group number of lithium? If you look at the periodic table, it's in group 2. You could also say the alkali earth metals is the group that it's in. How many energy levels or electron shells does lithium have? So that's the periods. So you count, this is period 1, lithium is in period 2, so it has 2 electron energy levels or electron shells. How can you calculate the mass number or atomic mass for an atom? So to calculate the atomic mass of an atom, you add the protons and the neutrons together, and that is the atomic mass, or some people say the mass number. Number 30, this element has 5 energy levels and 8 valence electrons. So if you look on a periodic table, you want to look and go down to the 5th period. So this is the first period. Remember, each period represents an energy level or energy shell. So this is the first period, 2nd, 3rd, 4th, 5th, and we want to go over to where the noble gases are. They have 8 valence electrons, and the element that's there is xenon. Okay, so the answer for that would be xenon. Let's go to the next one. This element is in the family with the most reactive nonmetals and has 4 energy levels. It must be what? The most reactive nonmetals are the halogens. So, or group 7A. And 4 energy levels is 1, 2, 3, 4. In the halogens is this element right here, which is bromine. Okay? Let's look here. Review the lab safety rules. You guys know those. Just go back and look over. You can Google that if you need to. But be prepared to answer some questions about lab safety rules. Which SI unit is used to measure length? Meters. Remember, the SI units that we talked about in class are meters, liters, grams, and seconds. So, to measure length, you would use meters. The SI unit used to measure mass would be grams. The SI unit used to measure volume would be liters. Number 36, what lab equipment would be best used to measure out large amounts of water? So, it depends on what lab equipment is available, but you could use a graduated cylinder if it's big enough to hold, like if you need to have 1 liter, you would have to have a 1 liter graduated cylinder, or you could have a beaker. If you wanted to measure it accurately, like precisely 1 liter, then it would have to be a graduated cylinder. Number 37, what lab equipment would be best used to measure out small amounts of a liquid? So, for instance, let's say like 13 milliliters of water. That would be a graduated cylinder as well. You could also use a pipette if you needed to. Number 38. Practice reading mass on a triple beam balance. So there will be a question on the test, a picture of a triple beam balance, and you need to be able to read the weight that is on the mass that is on that balance. Number 39, how do you find the volume of a substance that is irregularly shaped and is fairly small? So in order to find the volume of something that is irregularly shaped, we have to do what's called taking the volume by volume displacement. And that's where you add a known amount of water in a graduated cylinder, then you drop the substance in there and you notice how much the water moves, and then you take the ending result of the volume of the water in the graduated cylinder, and you subtract the 2 amounts, and the difference of those 2 levels of water is the volume that you list as your irregularly shaped object. Number 40, how do you find the volume of a rectangular solid? That is simply the length times the width times the height. Number 41, convert 1 kilograms to grams. So this is where you're going to be moving down that metric ladder. Kilogram is at the top, and grams is 3 steps down to the right. So that means we're going to take our decimal and move it 3 places over to the right. Remember, if you don't see a decimal, you have to assume that there's one there at the end of the number. So converting 1 kilogram to grams would be 1 kilogram is equal to 1,000 grams. 45 centimeters to meters. Centimeters is 2 steps down from meters, and so to go to meters, we would have to go 2 steps up or 2 steps to the left. And so we would move our decimal place 2 places to the left. So 45 centimeters is equal to 0.45 meters. Convert 5 meters to millimeters. Okay, millimeters is 3 steps down from meters. So that means we have to do this, or 3 steps to the right of meters. And so that's what we have to do with our decimal place. So we take our decimal place, which is an imaginary one after the number 5, and we move it 3 places to the right. So 5 meters is equivalent to 5,000 millimeters. Define observation. An observation is something that you can experience and note with your 5 senses. You see it, you can touch it, you can taste it, you can smell it. It's something that you visually experience or see. And it's indisputable. Okay? An inference is something that you a conclusion that you come to based on an observation. Now, an inference may or may not be true. You may think this happened, but it may not have, based on your observation. And so an inference can be debatable, it can be disputed, but an observation is a fact. A solute is something that is being dissolved. A solvent is the substance that is doing the dissolving. So, for instance, remember when we made lemonade in class, the solute was the lemonade powder, the solvent was the water. Define the law of conservation of matter. The law of conservation of matter states that matter can be neither created nor destroyed, only transferred and transformed. Number 49, state all the points of the kinetic molecular theory. Okay, the kinetic molecular theory, the most important part of that is that particles are in constant motion at all times. You never have particles that do not have motion. Define the heat of fusion. The heat of fusion is the amount of energy that it takes to change a material from a solid state to a liquid state. And so if you're talking about water, that would be the amount of energy needed to change water from a ice or solid to a liquid. Okay? Good luck. Y'all keep studying and do good on your exam.